Hello, this is Mrs. Butcher. This video is Relations and Functions. It's 2.1 in your book. All right, we're going to start with definitions. A relation is a mapping or pairing of input values with a set of output values. The domain of all relations is the set of all input values, otherwise known as your X values, your inputs. That's the independent variable, and we plot that on the horizontal axis. The range is the set of all output values. That's your dependent variable, and that's plotted on the vertical axis. That's your Y values. All right, there are several different ways we can represent relations. One of those is a set of ordered pairs. So an example might be -2, 2, and -2, -2, and 0, 1, and 3, 1. So that's a big set of ordered pairs. We could also represent these a relation with a table. So if we made a table with the same ordered pairs that we just used, all the x's would be -2, and that corresponds to a y of 2, -2 and -2, 0 and 1, 3 and 1. We can also represent a relation with a graph, so we could graph everything that was in our table. So for this relation, -2, 2 would be about right here, -2, -2 would be right here, 0, 1 would be here, and 3, 1 would be here. Another thing you could do is what we call a mapping diagram. And what you do is you write all your inputs in one group and all your outputs in another group, and then you draw arrows like this. So our inputs here, the inputs being the X values, we have -2 as an input, we have 0 as an input, and we have 3 as an input. I don't need to write -2 twice, it's only one value. And then our outputs that we have, the lowest is -2, the next lowest is 1, and then the highest is 2. And then we just draw arrows. So -2 maps to +2, if you look at this one, -2 to +2. It also maps to -2, 0 maps to 1, and 3 maps to 1. So that would be a mapping diagram of this same relation. So now for an example of a problem you might see, we might ask you for the relation above, the one we just did, because they were all the same values, give the domain and range. So our domain, if you remember, is your X values, and you can write D for domain if you want to. And since this has very specific X values, it's not a continuous function, it's just dots, we're going to use the braces, or the fancy brackets, and we're going to list our X values from least to greatest. So -2 is the lowest, and then 0, and then 3. Make sure you do it from least to greatest. Our range would be the Y values listed from least to greatest. So the lowest Y value was -2, and then the next was 1, and then the highest was 2. And these are specific values, so they go in fancy brackets. Okay, let's do another definition. We're going to define a function, and that is a relation in which each input has exactly one output. Highlight exactly one output. So each X value that you have only has one Y value associated with it. If you've got an X value that has more than one Y value associated with it, such as in the relation we just did, then it is a relation, but it's not a function. So make sure you know this, and when you're asked if something is a function or not, you use these words. Each input has exactly one output. Or if it wasn't, you would say each input has more than one output. Now, a really good visual way to check if a function is a relation or not is to use the vertical line test. And that says that a relation is a function if and only if no vertical line intersects the graph of the relation at more than one point. So here's an example of a function, and here's an example of a graph that is not a function. So you see the second graph has a vertical line that intersects it more than once. That means it's not a function. Each of these input values, all of these input values over here have more than one output. So it can't be a function. So for this example, I'm going to give you a bunch of different relations, and you are going to tell me whether those relations are functions or not, and explain your answer. Then I'm going to ask you, state the domain and range in interval notation. Okay, our first function is a set of ordered pairs. We've got 0, -2, 0, +2, 3, -1, 3, +1, and 4, 0. Is that a function or not? Well, we look and we see, do any of the x's have more than one y value? And we have that happening here, because 3 has -1 and +1, and here 0 has -2 and +2. So no, it is not. And when it says explain, we're going to say no because some of the inputs have more than one output. Okay, now here's another one. Look at this table. Move it down a little bit. Our x's, -2, -1, 0, 1, and 3. Our y's are -4, -4, -4, -4. So if we look at this, each input that we have only has one output associated with it. None of our x's are repeated. So what we're going to say is yes, because each input has exactly one output. Now, I also asked you to give the domain and range and interval notation. So let's go back to the first one. We're going to put a D for domain, like this, and then we're going to write all the x's in numerical order from least to greatest, like this. And we don't write the ones that are in there twice. You just write 0, 3, and 4. Those are our inputs. For the range, we're going to list the y values in order from least to greatest, so -2, and then -1, and then 0, and 1, and 2. And remember, when we're doing specific values, we use the fancy brackets. All right, for the second one here, the one in the table, the domain for this, it's just going to be these x values right here in the chart, so we'll write that down. And then the range, the only y value, the only output that we have is -4. So our range is only -4. And that is it. Okay, here's a graph. Same thing. Is this relation a function? And so this one we can apply the vertical line test. And when you look at it, it looks as if your graph is overlapping right here. But because there's a closed circle here and an open circle here, it's actually not overlapping. It's going all the way up to this value, and then when it reaches it, it jumps up. And same thing here. So this actually is a function because each of our inputs only has one output. -1 only has that output at 0 because the open circle doesn't include it. Our domain for this function is all of the x values. So let's look closely at this. The leftmost, the lowest x value we have is -3, and it does touch it. And then it is continuous all the way up to -1, and then it's still continuous all the way up to 2, and still continuous all the way up to 4. So we're going to end it at 4, and since there's an open circle on that end, we're putting a soft bracket. Now the range, the y values, that's not continuous. That's discontinuous. There is one y value at -1. There's another one at 0. And then this y value is +1. And those are the only y values that we have in this graph. So that's our range, those 3 specific values in fancy brackets. All right, and finally, look at this graph. Does this one pass the vertical line test? Yes, it does. Any vertical line that we were to draw on here would only cross it one time. And our domain for this one, it is continuous. It starts at x's -5, but it doesn't touch it. And then all the x's are represented all the way up to 7, and it doesn't touch 7 either. The range on this one is just a little bit more tricky. We have to look at the lowest y value. You aren't going to look at the end of the function. You're going to actually look at what is the lowest y value. And in that case, it is -6. And it's touching it. And then you look at the highest y value, which is 8. And it's an open circle, so it's not touching it. So this end doesn't have anything to do with the range because it's right in the middle there. All right, our next example. Tell whether the function is linear and find the indicated value of f of x. So if something is linear, that means the highest power on your x is going to be 1. So if you look at example A here, we have an x squared. That means it's not linear. So not linear. And then find f of -4. That just means you plug in a -4 everywhere where there was an x. So we're going to say -4 squared minus 2 times negative 4 plus 7. When I square negative 4, I get positive 16, but then I have this negative on the outside also, so that goes there. Don't look at this as negative negative is a positive and then positive squared is a positive, because remember PEMDAS, the exponent here comes before the multiplying here. All right, then we have minus 2 and minus 4, that's plus 8, and then plus 7. Negative 16 plus 8 is going to be negative 8, and negative 8 plus 7 is negative 1. All right, now a b, the highest power is 1, so this is linear. And then g of negative 6 means you replace the x with a negative 6. 5 times negative 6 is negative 30, plus 8 gives you negative 22. All right, example 4 says plot the graph of the function and tell the range. So I'm going to give you a domain that you have to limit your function to, and you're going to tell me the range that goes with it using interval notation. The first one is y equals 0.8x squared in the domain negative infinity to positive infinity. So if we graph this parabola, you're going to get, well, I mean, if we graph this quadratic, you're going to get a parabola, and since the domain is all real numbers, it's going to have arrows on both ends, like so. So now when we give the range, we're talking about the lowest y value, which is down here at 0, to the highest y value, which, because there's arrows, it's going to infinity. Okay, the next one, y equals 0.4x plus 5, that's a linear, but we're limiting the domain from negative 2 non-inclusive to 6 non-inclusive. So that's going to be a line, but it's limited, so it's actually going to be a segment. And because it's non-inclusive, we're going to have open circles on both ends of that segment, so it will look like this. So the range for this function, the lowest y value, it's hard to tell just by looking at this graph, but the way you're going to figure it out is you're going to plug in your lowest x value and solve. So negative 0.4 times negative 2 plus 5 gives you 2.6. So we now know that that y value is 2.6 and it's not touching it. So that's the range. And then to find the highest y value, don't just estimate, don't just guess that it's 6 or anything like that. Plug in your 6. Y equals negative 0.4 times 6 plus 5. When you do that, you get 5.8. So that is the upper limit of your range there, 2.6 to 5.8. You always want to make sure you plug in the values of your domain and for x to figure out your exact values for y. All right, and then the third example of this, y equals the absolute value of x minus 3. I don't know if you remember this or not, but absolute value graphs make a V. And when you graph that, we're going to limit our domain to 0 to 7. So you can do this in the calculator, but you want to make sure that you limit the domain. So let's look at what that would look like. All right, so this one looks like this, but we've got limitations, so it's got a closed circle because of both of the hard brackets on x is 0 and x is 7. When you look at the range, the lowest y value is 0, and the highest y value is up here at 4. All right, and then our last example, sketch a graph of a function with the given domain and range. So I might give you a domain and range that you have to fit a function into. A trick that I always use, you don't have to do this, but I look and I say, okay, my domain is from negative 3 non-inclusive, so I put a little dotted line through x is negative 3, and 7 inclusive, so 1, 2, 3, 4, 5, 6. I put a solid line through the 7. These are just little guidelines from myself. They're not my graph. Then the range is negative 5 inclusive, so there's a guideline for myself. I just like sketch these lightly, usually with my pencil. And then 6 up here, and those are both solid because they're inclusive. So that tells me that my function has to fit within that rectangle. It has to have an open circle somewhere on the dotted line. So I'm going to change my color real quick. We'll put an open circle. It doesn't matter where, anywhere on the dotted line. But it can't be closed. It can't touch it. And then I have to touch the top, I have to touch the bottom, and I have to touch the right. Now, because these two come together, I can touch them both at the same time if I want to. But I still have to touch the top, and then I have to touch the bottom. Now, that's just one example of something that would fit in there that is a function. Another thing is I could put, my open circle, and I could go to the bottom, and then I could go up here, right? Or I could put an open circle over here, and I could go to the bottom and the top and come back down. It doesn't matter. As long as it's a function, meaning it passes the vertical line test, and it open circles on the dotted part and then touches the other parts. So there'll be some practice problems like that on the homework. All right, well, I have to rush, so I'm not going to give you a joke. I'm sorry, but have a good night, and I will see y'all tomorrow.